Here we're going to do units and dimensions, the usually asked question to derive an expression purely by using dimensions. Okay, so I'll do many questions could be asked. I'll do the common one. Derive an expression for time period of a simple pendulum, provided that it depends upon the length of the pendulum, it depends upon the mass of the bob, and also depends upon the acceleration due to gravity. So given these information, we have to evaluate, or we have to find an expression that connects the time period, how much time it takes to complete one oscillation. And we don't use any physics over here, it's purely using dimensions. Okay, so the way we do this is following. I know that t is proportional to length, but I don't know exactly how it's related. Is it directly, is it inversely? So I just say it's some power x. Similarly, it's proportional to mass, some power y. It's proportional to acceleration to gravity, some power z. If I know what x, y, z are, then I will be able to write an expression. So together I can write this as L power x, m power y, g power z, and we can always replace that proportionality with some constant. Okay, here is where we're going to use the principle of homogeneity, very important principle, which basically states that if you have an equation, then the equation can only be dimensionally correct provided the dimensions of all the terms on the left side should be equal to dimensions of all the terms on the right side. So dimensions of the left side term should be equal to dimensions of all these terms together. Okay, what is dimensions of t? Well, that's just t. K constant does not have any dimension. It's a dimensionless constant here. L is length, so I can just call this as L power x. M is mass, m power y. And g is acceleration, centripetal acceleration, gravitational acceleration doesn't matter. It's acceleration, that's all that matters. Lt power minus 2, and that's a z. There's a z. So together I can write this as L power x, m power y. I have an L power z here. I have a t power 2z. Okay, I'm just gonna put that, differentiate 2 and z. Okay. Alright. And so if I look at this, I have L power x plus z, I have an m power y, and I have a t power 2z. And left hand side I can just write it as L power 0, m power 0, and t power 1. And now I can equate them. L power 0 should be equal to L power x plus z. That immediately tells me that x plus z equals 0. Oh, z, yeah. So x equals minus z. I have m power 0 equals m power y. That tells me y equals 0. And I have t power minus 2z equals t power 1. That tells me that minus 2z equals 1, or z equals minus half. I can substitute that over here, and I get x equals plus half. So I have what x, z, and y are. Now I can substitute that in this equation, which I'll call as equation 1. And so now I'll write this in yellow. I have my final expression ready, and that's going to be t equals k into L power x, that is half. I have m power 0, and I have g power minus half. I can write this in a little civilized manner. It will be root of L over g. That is the expression. It's independent of mass, and the value of k cannot be found out. Now in reality, yes, k equals 2 pi, but our derivation stops over here. You're not supposed to write this in your exam, because there's no way you know how k equals 2 pi just because you've seen it in your books. But the derivation stops here. Don't substitute the value for k. You're not supposed to. That's where it stops. So that's how you use dimensional analysis and principle of homogeneity to figure out the derive expressions.